Part 4, Sketching Rational Functions. Identify the intercepts and asymptotes, then graph f of x equals 1 over x plus 2. So the x-intercepts. The x-intercepts are where the function equals 0, and 1 over x plus 2 equals 0. That will happen when the numerator is equal to 0, and since 1 will never equal 0, there are no x-intercepts. The y-intercept. The y-intercept is when x is 0, so 1 over 0 plus 2, which is 1/2. So the y-intercept is the point 0, 1/2. And I'll graph that point. The vertical asymptote is where the denominator equals 0. So where x plus 2 equals 0, or x equals -2. So our vertical asymptote is where x is -2. And I'll draw that as a dashed line. And then the horizontal asymptote. Look at the degree of the numerator and denominator. The degree of our numerator is 0 because we have no x's in the numerator. The degree of the denominator is 1. So if the numerator has a smaller degree, the horizontal asymptote is the line y equals 0. And I'll graph that asymptote. So we only have 1 point on there. We know there are no x-intercepts. And we know that as x approaches infinity, we're going to get closer and closer to the horizontal asymptote. And we know that we're going to get closer to the vertical asymptote as we approach that. But we need a few more points to decide what's going on here. So let's come up with a few more points. Let's say what happens if x is, let's say -1. If x is -1, we would have 1 divided by -1 plus 2, which is 1 over 1, or 1. So we have a point at -1, 1. What about if x is, let's say, -3? If x is -3, then we would have 1 over -3 plus 2, which is 1 over -1, or -1. So -3, -1 is another point. Now we know we're not going to cross this horizontal asymptote because the horizontal asymptote is the x-axis and there are no x-intercepts. So we know we're not going to cross the horizontal asymptote. Because there's no vertical asymptote in between these 2 points, they are going to connect. And then we're going to start getting closer to the asymptotes. On the left of this vertical asymptote, we know that we're not going to cross this x-axis, but we do have to get closer to it because it's an asymptote. And then we need to start approaching the vertical asymptote also. So this is what our graph will look like. You can plug in as many points as you want. I only found 2 extra points, so 3 points altogether, including that y-intercept. But until you get really good at this, find a lot of extra points. The more you find, the better your graph is going to look. Let's do the same thing with this function, f of x equals x plus 1 divided by x minus 2. So the x-intercepts are where the numerator is 0. So we get x plus 1 equals 0, or x is -1. So my x-intercept is the point -1, 0. The y-intercept is when x is 0. So if I set all the x's equal to 0, I get 0 plus 1 over 0 minus 2, which is 1 over -2, or -1/2. So my y-intercept is the point 0, -1/2. The vertical asymptote is where the denominator equals 0, so where x minus 2 equals 0, or x equals 2. So the vertical asymptote at x equals 2, and let's draw that asymptote. And then the horizontal asymptote, if we look at the degree of the numerator and denominator, the numerator has degree 1, the denominator has degree 1. They are the same. So we look at the leading coefficients, which is 1 over 1. So y equals 1 is our horizontal asymptote. So we have 2 points, and we do have the horizontal asymptote. We need to decide if we are going to cross that horizontal asymptote. To do that, I can set my function equal to 1. 1 is the horizontal asymptote. If I get an answer for x when I try to solve this equation, then that will tell me where I cross the horizontal asymptote. In this one, if I multiply both sides by x minus 2, I get x plus 1 equals 1 times x minus 2. Subtract x from both sides, and I get 1 is -2. which is not true. So we do not cross that horizontal asymptote. Let's find a couple of extra points. So let's look at, we have a couple of points to the left. Let's look at a couple of points to the right of that vertical asymptote. So let's try x is 3. If x is 3, I have 3 plus 1 over 3 minus 2, which is 4 over 1, or 4. So I have a point at 3, 4. 1, 2, 3, 4, about right here. Let's see what happens if x is 5. So if x is 5, I have 5 plus 1 over 5 minus 2, which is 6 over 3, or 2. So we have a point at 5, 2. So on the right side, these 2 points need to connect, and then we need to get closer to both the horizontal and vertical asymptotes. And on the left side, same idea. We know we're going to cross through the x-axis at that x-intercept because we got that x-intercept from our numerator, x plus 1, and that factor has an odd degree, degree 1. So just like with polynomials, we will cross through the x-axis there, not touch and turn around. Let's find an equation for a rational function r of x that has an x-intercept 0, 0. So let's start with that. If the x-intercept is 0, 0, we know we have an x minus 0 in the numerator, which we can just write as x. It might be an x squared, an x cubed, I don't know yet, but I'm going to just start with x. The next thing says we have a vertical asymptote at x equals 1. That means x minus 1 will be a factor in the denominator. Because when x is 1, now our denominator equals 0. And then it says we have a horizontal asymptote of y equals 2. So I know my leading coefficients need to be 2 over 1. So I'll put a 2 in the numerator. I don't need to write the 1 in the denominator in front of the x, although I could. And then it says the degree of both the numerator and denominator is 1, which is true. I have the degree of the numerator and denominator are both 1. And so this seems to work. This matches all of the conditions that were given. So we did find this equation that matches this.